All right, everybody. So for today, we're going to be working on an assignment. That's all it is. You actually have notes on this already. So even though we call it classwork 9.0, it's the start of Unit 9. Back in Unit 8, we had a concept called exponential growth and decay, where we talked about what makes something growth versus decay. Some of you saw this question on the SBAC. But here's where we had problems where we use the growth formula or the decay formula. So if you have these notes, it's going to help you work out these problems for today. But just to make sure that you're ready and can do this very well, here are the growth formulas. So remember, it's called a growth formula because we're adding to the rate, and here's what every letter represents, in case you forgot. And then for these two problems at the bottom, these are going to be, you're going to be using the exponential decay model. And the only reason that it's called decay is because you're going to put a minus sign instead. But again, it describes what every letter represents. So there's 4 questions on this page. I'm going to do one of them with you. So I want to do number 2. And if you notice, I would have Desmos ready at the bottom because we are going to need Desmos eventually for this problem. So I want to do this problem with you for a reason. Let's read it first. In 2002, there were 972 students enrolled at Oakview High School. Since then, the number of students has increased by this percent each year. Write an exponential function to model the situation. So if you notice, they're asking me to just write an exponential function to model it, and then it says then find. So notice there is actually 2 parts to this question. They also want me to find the number of students enrolled in 2014. So basically, they started to look at the numbers in 2002. Now they just want me to see what the new population would be in 2014 based on the model we created. Well, if I'm going to use a growth model, just like it says here, 972 students, that would be my initial amount. So that would be my A value. So I'm just going to put an A. I know we could barely see it, but that's how we have this space. My A is equal to 972 in Oakview. Then the number of students has increased by 1.5%. Well, remember, it says R is your rate as a decimal. I would write up here, not a percent. So maybe that just sounds wrong. So let's look at the percent, we should say. So my percent here, my R, is 1.5%. But remember, in math, we don't actually use percentages. I need to use the decimal equivalent, which means a percent symbol has 2 zeros, and that's a great way to remind you that you always move twice over. So that means my R is see, we got that empty space, 0.15. That's my R, and that's why I wanted to do this one with you. The one on top is a little bit easier to move the decimal twice. So remember, it's not 0.7 up there. It would be 0.07 for that one. But I wanted to show you this one because of that extra number, the 5. All right, so I've got my R, I've got my A. Now, in the first problem, they said, write the exponential function. Okay, well, here comes the formula. The formula, so this is part 1, I'll call it A. Y is equal to A, 1 plus R to the power of T. And the reason I'm using the plus, they said it's increasing. All right, well, I have my formula, so I don't really need to be up there anymore. I don't need to see the top part. All right, well, Y is equal to, A is 972, 1 plus, my R, don't forget, is 0.015, not 1.5. And then the power of T. When you're creating the exponential function, we actually don't plug in a T yet. So here it is, 972. 1 plus this is just 1.015. And remember, the reason why it's also considered growth, this number right here is more than 1. That's why we call something growth as well. If my number were less than 1, well, that's when I would talk about decay. All right, well, now they want me to find the number of students in 2014. And this is where you have to be careful. So for the letter B, we have to know what T is. Well, I'm not going to write 2014. That's an actual year. So you got to think about a time frame. This is another reason why I wanted to do this one with you. They started in 2002. They want to know what it's going to be in 2014. So what I want to know is how many years are between 2002 and 2014. Well, there's a very easy way to do this. Take the bigger year, subtract the smaller year, and now we know that that's 12 years. So that's what my T is going to be, 12, not 2014. Well, you already have a formula. You just have to plug it in. Y is equal to 972, 1.015 to the power of, and now instead of a T, that's where my 12 is going to go. So now I'm going to very carefully type this in. Now, keep in mind, we are talking about a population. So when we talk about decimals, we need to be ready with that. Okay, so let me move this over here so you can see it. I'm just using Decimal Scientific. This is the easiest one to use. So I'm going to go 972 parentheses 1.015 close parentheses to the power of, and then here comes the 12. Now look at that decimal right here. That's a 0.14. Well, what you have to keep in mind, and let me write this number down so that we can just see it here. So the number is 1162.140 ... So what I was trying to get at earlier was this. If we are talking about population, you don't say there's a decimal of a person. You have to cut it off at a whole number. And if it's, my answer is either 1162 or 1163. Well, it's just a little one next to it. So we are going to say that the population of this high school is 1,162 students by the year 2014. So by that year, that's how many students we're going to have at that school. Now, obviously, every problem is a little bit different when it comes to this. Here, we're talking about people. So let me move this out of the way here. Up here, they're talking about money. So if they're talking about money, well, then, of course, that one I will do 2 decimal places. So you do have to pay attention to the context of the problem. And the other thing I wanted to mention, again, they gave me years. So you saw how we found the time. Look at this one. This one literally says 15 years. Well, then there's your T. T is 15. See, here they're giving it to me in problem number 1. Here, I had to figure it out. So just be careful. But you only have 3 more problems on this page. Remember, this one's obviously with the one with the plus. The ones down here are going to have that minus sign. So very similar, though. Same setup for all of them. Plug it in. Let the calculator do the work. But if it's money, you need 2 decimals. If we're talking about people, whole numbers only. So now flip the paper over. Like I said, you have 12 questions total for today. And we're going to do 3 of them. Look, we already did this one here. So we're going to do 2 in the back, right, just to show you. So let's do number 5, just because it's there. Now notice, this one has a plus sign, which means this number is going to be bigger than 1. So the question says, does this function represent growth or decay? Well, clearly this is growth, and we know that because of the plus sign. That's how we know it's growth. It's 1 plus r. What is your initial value? Well, look, if I look at my formula, this is my A, this is my R, and remember, because it's 1 plus r, so the R is already there, and my A was already handed to me. I don't really have to do any work on this page. They just want me to look at an equation and learn how to pull things from it. So on this one, they said, okay, well, what's your initial value? Well, then they started with 1,200. There, we've got this answer. So see, this one's done. But now you have to watch out for this one. We know it says R is equal to 0.3. But they said, what is the rate of growth? A rate of growth, because that's what this is a percentage. So now they want me to go backwards. See, over here we said, if I want to turn a percent back to a decimal, I move it twice to the left, because I got to make this really small number. Well, now they're asking me, well, what is the percentage? Well, then that means I got to, here's my decimal. I got to move it twice back this way. So then my answer for R is going to be 3 with an extra space makes it 30, so 30%, because we have to bring in this extra 0 right here. So just remember, it just depends how they phrase the question. Here they want a percentage. Well, there's my percentage. Now, there is another one I want to do with you here. I want to do number 8 with you, because if you notice, this thing doesn't have a plus or minus. Now, neither does number 7. But I want to show you one of these. So when I look at this number, the mistake that people make is they go, oh, that's the R. It is not the R. It's only the R if you see it with a plus sign. See, this one here has a minus sign. Yeah, that's your R. This one, though, this is smaller than 1. So because it's smaller than 1, this is decay. And look at the difference. Over here I wrote A, 1 plus R. Here this is decay. So yeah, there's my A, but this is 1 minus R because it's decay. It's less than 1. All right, so this question says, okay, well, tell me what the initial value is. Well, there's the initial value. This one never needs any work. It's just there. This one needs work. See, they said 0.65 is 1 minus R. There's no minus sign here. There's no 1 up here. Then that means I'm going to go 1 minus R equals the 0.65. So you actually have to do a little bit of work here. Unlike this one, that one already had a plus sign. This one already has a minus sign. Not a lot of work there. It was ready. But this one does. We have to find what R is. Then subtract your 1. Let a calculator help you with that, of course. So let's see. I've got this old school one here. Just do it on Desmos for yourself. 0.64 minus 1. So I've got negative R equals negative 0.36. Well, remember, we don't want it to be negative. Divide by negative 1, and there it is. R equals 0.36. But remember, they want a rate. They want a percentage. So if your R is 36 right there, right, you're going to move it twice. So then your R is 36%. So yes, if it has a plus sign or a minus sign, there's your R right away. Look at this one right here, number 6. 1 minus R, that makes it decay. But there's your R right away. Yeah, this does not say 1 minus or 1 plus, but it's growth because it's bigger than 1. So that's growth, but you're going to have to find out 1 plus R is equal to this, kind of the way we did this one with the 1 minus R. So some of them do require a little bit of work because they don't have a plus sign or a minus sign. So you do this, you make it equal to each other so you could do a little solving to find it. All right, everybody, well, that only leaves you with like 9 more questions to do. So hopefully it all goes well. Double check your answers, but this is due before you leave.